Hello, this is Sal. In today's video, we will be talking about configuring multi-area OSPF version 2. In this topology diagram, I already configured the interfaces and the loopbacks, everything here, but if you download the walkthrough documents and the packet tracer, you will be able to configure them on your own. But for now, to make OSPF more efficient and scalable, OSPF support hierarchical routing using the concept of areas. An OSPF area is a group of routers that share the same link state information in their link state database, LSDB. When a large OSPF area is divided into smaller areas, it's called multi-area OSPF. Multi-area OSPF is useful on large network deployments to reduce processing and memory overhead. In today's lab, I will configure a multi-area OSPF version 2 network. I will configure the devices, names as shown in the topology, and configure the IP addresses on the interface and set the bandwidth on the interfaces to 128 kilobit per second. As I said, I configured the interfaces already, and now on the routers, I will configure the bandwidth on the interfaces for the routers to 128 kilobit per second. So on router 1, enable configure terminal interface serial 000, bandwidth 128, and that's it. Now on router 2, we have two interfaces. Enable configure terminal interface facing router 1 on serial 000, bandwidth 128, and the other interface facing router 3 on serial 001, bandwidth 128. Now on router 3, I'll do the same. We have only one interface facing router 2. Enable configure terminal interface serial 001, bandwidth 128. Now I will verify the connectivity between the routers by running the show command on router 1 and router 2 and router 3. Here on router 1, in show IP interface brief, and showing us here the interface serial 00 is up and up, and the loopback 0, the one connected to the internet, is up, and the two loopbacks, loopback 1 and 2. Same on router 2, show IP interface brief, everything is okay. Here, the two interfaces and loopback 6, and the same on router 3 here, show IP interface brief. We have the on router 3, the serial interface is up, and the two loopback 4 and 5. Now I will ping the interfaces here from router 3. I want to ping router 2 interface, the one is facing it, 172.16.20.1, and it is, and from router 2 I will ping the 172.16.10.1. Now, after verify that the pings were successful, and you can also run the pings when you download this from this interface to this interface and this interface to this interface here. After we verify that the pings were successful, it's time to configure multi-area OSPF version 2 network. I will configure it with the process ID 1, and all LAN loopback interfaces should be passive. Here, by looking at the topology diagram, router 1 and router 2 are both backbone routers. Why? Because both routers are in area 0. Router 1 and router 2, they are both in area 0. That's why we call them the backbone routers. The ASBR autonomous system boundary router is only router 1 here. Why? Because it's connected to the internet. And the area border router, ABR, routers are router 1 and router 2. Why they are area border routers? Because router 1 is located in area 0 and area 1. In here, this side, these loopbacks in area 0 and in area 1 and area 0, and router 2 between area 0 and router 3. That's why we call them the ABR routers, or area border routers. And router 3 is the internal router, this guy here. Why? Because it's placed in one area, just one area, router 3, which is area 3. On router 1, I will configure OSPF. The router ID for router 1 will be 1.1.1.1 with the process ID of 1. And the loopback 0 connected to the internet, I will configure it with a default route. So on router 1, here, configure terminal, router OSPF with process ID 1. Now router ID 1.1.1.1. Now the networks on router 1 are the two loopbacks and the interface here, 172.16.1.0. This is for loopback 1, and with the inverse subnet mask 0.0.0.255, and both are in area 1. Sorry, this loopback in area 1, loopback 1. Now for the network of loopback 2, 172.16.2.0, with the inverse subnet mask of this, and also loopback 2, as you can see from the diagram, in area 1. Area 1. Now the interface of serial 000, this is in area 0. Network of 172.16.10.0 with the inverse subnet mask of this. That's free because this is a /30, and this is in area 0. Now I will set the LAN loopback interfaces in loopback 1 and loopback 2 as passive. Here, exit, passive, this will be router OSPF 1 passive interface loop back 1 and passive interface loop back 2. Also here we still on router 1, I will create a default route to the internet using loopback 0 interface. Exit. Now default route IP route 0000 and with 0000 and the interface for loopback 0, the loopback connected to the internet. Here we will notice that the default route without gateway, it's telling us default route is without gateway, and the point-to-point interface may impact performance. This is normal if using a loopback interface to stimulate a default route. Now, I will configure the OSPF to propagate to the routes throughout the OSPF area. on router 1, and with this command, router OSPF1 default information originate. This is on router 1. Now on router 2, the ID for the router will be 2.2.2.2. Configure terminal, router OSPF process ID 1, router ID 2.2.2.2. Now we have here the networks on router 2. Configure them with OSPF network of the interface facing router 1 and the interface facing router 3, and then the loopback. So now let's start with the 172.16.10.0, the interface facing router 1 area. This is in area 0, and the other interface facing router 3, that is in area 3. So upper arrow, this is in area 3, and this is 20.0. Now the loopback network of 172.16.6.0 with this inverse subnet mask, and the loopback 6, this is in area 3. Sorry, area 3. Now I will configure a passive interface just for the loopback 6, which is passive interface loopback 6 on router 2. Now router 3, the router ID for router 3 is 3.3.3.3. Configure terminal, router OSPF1, router ID is 3.3.3.3. And now the network, we have the interface facing router 2. We have for loopback 4 and 5, they are in area 3. So start with the interface network of 172.16.20.0, the 3 area 3, network of 172.16.4.0, area 3, and the network of 172.16.5.0, and this is also in area 3. We have two loopbacks to configure them as passive interface, which is loopback 4 and loopback 5. Now, after done with the routing protocol OSPF configurations, I will verify that the OSPF settings are correct and adjacencies have been established between the routers. I will run a show command on the routers to verify the settings on each router and to identify the OSPF routers types and to determine the network assigned to each area. Now start with router 1. Show IP protocols. As you can see here, it's showing us that we are using the protocol OSPF. The router ID on router 1 is 1.1.1.1, and here is showing us that this is an autonomous system boundary router. Why? Because loopback 0 is connected to the internet to another autonomous system. And here is saying we are using this to route for this network, the loopback 1 in area 1, and loopback 2 also in area 1 here, and the interface facing router 2, which is in area 0, which is this interface. And we have the passive interfaces for loopback 1 and 2, and routing information source here. The gateway is on router 1, this router ID, and this the distance is 110, and this is on router 1. Give us good information about the protocol being used here. And on router 2, show IP protocols. And here also showing us the protocol being used is OSPF, and the number of areas in this router are 2, and telling us that we are using this router to route these networks, which is the interface facing router 1, interface facing router 3, and loopback 6, which is in area 3. And the routing information source, the gateway for what we can find here, the gateway for router ID for router 1, and this is for router 2, and this is for router 3, and this is the administrative distance here. The same with router 3. Show IP protocols. And here showing us that OSPF is being used here, and the router ID is 3. Areas on this router, only one router, and it is routing these 3 networks. The interface network with the interface facing router 2, and the 2 loopback 4 and 5. Now, I will need to run a command to verify that OSPF adjacencies has been established between routers. On router 1 and 2 and 3, start with router 1 here, show IP OSPF neighbors, and here show router 1, the neighbor is router 2. This is connected to router 2, and with this router ID, and the address on this interface is 172.16.10.2, and it is connected on this interface. And on router 2, show IP OSPF neighbors. Now it is router 2 is connected to router 1 and router 3. These are the IDs for the routers on router 1 and on router 3. The state is full for both routers, and this is the IP addresses where are they connected. This is on for the router 1, and this is for router 3 connected via this interface. Now I will run this command on router 1. I keep shrinking because I'm trying here show IP OSPF interface brief. This is not supported by a packet tracer, but I will remove delete brief, and this is supported in packet tracer. Here it's showing us the interfaces. Here for loopback is up. This is on router 1. Line of protocol is up. The internet address is for loopback 1 is this in area 1. Process ID for router is 1.1.1.1. Loopback 2 is up. and it is giving us good information on this router. The same with router 2, show IP OSPF interface. It's showing us the serial 00 is up. This is on router 2, which is this interface. And the router ID is 2.2.2.2. The type is point-to-point. The cost is 781. Priority 0. And for the other serial interface facing router 3, and this is the process ID, the internet address for this interface is facing router 3 is 20.1. In area 3, the cost is 781. And the loopback is up. And this is for loopback 6. And it's loopback 6 in area 3, and the cost is 1. This is for here. On router 3, we have 2 loopbacks. The cost will be also 1. Here on this command, show IP OSPF interface. For the serial, the cost is 781, but for the loopback, the cost is 1, only 1. And everything is up and up. And here for loopback 4, and this is the IP address, internet address for loopback 4, and it is in area 3. The process ID for OSPF is 1. The router ID is 3.3.3. This is for router 3. And the cost is 1 for the loopback. Everything you saw in the video, you will find it explained in details in the walkthrough documents if you download the description, in the description of this video, and if you when you download the packet tracer. I hope you learned something from this video. I try to explain it in a very easy way, just keep it simple, and to make things easier to understand. Please, if you like this video, please share the video and subscribe to my channel and give me the thumb up. If you have any comments, please write me and I'll get back to you. Thank you so much for watching, and I'll see you in my next video.